So previous class we got to know about the atomic number and the atomic mass number. So based on that, today we will discuss about the isotopes. So isotopes are dependent upon the atomic number and the atomic mass number. So let us see what are these isotopes. So the isotopes, the atoms of the same element having the same atomic number but different mass number are called isotopes. So the atoms of the same element having same atomic number but different mass number are called isotopes. Example H11, H21 and H31. So isotopes. Students, isotopes are nothing but the elements, atoms of the same elements. Okay. So elements whose atomic number will be same but the atomic mass number will be different. So I will repeat it once again. Atomic number of the atoms of the element will be same. Atomic number will be same. So here you can see atomic number is same. Okay. But what will be different? Mass number of that element will be different. Atomic number will be same but mass number of the same element will be different. Such kind of elements are called isotopes. For example, hydrogen. You know the hydrogen atomic number of hydrogen is 1. So atomic number of hydrogen. Hydrogen is the first element of the periodic table, right? So atomic number of hydrogen is 1, right? But its atomic mass number, it is different. So hydrogen has 3 different mass number. That is, it has 1, 2, 3. So the first one, H11. So and you already know that the left side at the top it will be the mass number, whereas the left side at the bottom it will be the atomic number. Similarly, it's the mass number, it's the atomic number. And here too, 3, it is mass number, and whereas this one is atomic number. Okay, it's the mass number and it's the atomic number. So H11, this is nothing but the protium. Protium. H12, this is the deuterium, and H13, it is tritium. Alright students. So atoms of the same element, you can see there is a same element only, a single element, hydrogen, hydrogen, hydrogen only. But even that hydrogen, it has the same atomic number also. This hydrogen, its atomic number is same. This hydrogen atomic number is same, and even this hydrogen atomic number is same. 3 of the hydrogen element have the same atomic number, but what is different? You can see here mass number is different in 3 of the hydrogen elements. So such kind of elements are called isotopes. And this H11 is nothing but the protium, deuterium, H13 is the tritium. So these are the, what are the, if the question is what are the isotopes of hydrogen, then you have to write this one. H11 protium, H12 deuterium, H13 tritium. These are the 3 protium, deuterium and tritium. These are the 3 isotopes of hydrogen element. Clear? So next, isobars. What are these isobars? Atoms of different elements with different atomic number which have same mass number are known as isobars. Example, atomic number of calcium is 20, atomic number of argon is 18 and the mass number of both calcium and argon is 40. So isobars are nothing but it's the opposite. You can take it's the opposite of isotopes. So here what we have seen, atomic number is same but atomic mass number is different, right? But here it's the opposite. So here it will be atomic number will be different but mass number will be the same. So here you can see there will be different atomic number but mass number is same. For example, atomic number of calcium is 20 and atomic number of argon is 18. So calcium has 18 atomic number and argon has calcium has 20 atomic number and argon has 18 atomic number, but the mass number of both of these is 40. It's the mass number of calcium, and hence this is about the isotopes and isobar. So let us better understand it more clearly by taking still more example through this graphical video.
By now we are aware of what exactly the concept of atomic number and atomic mass is. Atomic number is simply the number of protons present inside the nucleus of an atom, whereas the atomic mass is the number of protons and neutrons present in the atomic nucleus. So when we have to represent both these entities for an element, how do we write it? Is there a specific way for representing it? Yes. The chemical symbol of the element is written with atomic number at its bottom on the left side, that is in subscript. On the other hand, the atomic mass is written on the top left side in superscript. Something like this. The symbol of the element, its atomic number and its atomic mass. Now how do we represent a simple element like carbon? That's right, something like this. The atomic symbol, that is C, followed by the atomic number 6 and atomic mass 12 at the respective places. Now what if it's another element, say chlorine? Something like this maybe? Yes, one type of chlorine atom can be represented like this. Why did I say one type of chlorine atoms? Are there more types of chlorine atoms? Yes. Some chlorine atoms have 20 neutrons instead of 18 in their nucleus. Then how do we represent this type? Yes, just like this representation. However, we now need to understand what exactly that is. There are many such cases where atoms of the same element exist in different forms. These forms are called the isotopes. Yes, in simple words, isotopes are defined as the atoms of the same element having the same number of protons but different number of neutrons. Yes, same number of protons but different number of neutrons. Just as we saw in the case of chlorine, all the atoms have 17 protons, but a few of them have 18 neutrons while some others have 20. So these are the isotopic forms of chlorine. Similarly, several elements have isotopic forms. For instance, we have carbon with 3 isotopes. As we can see here, each isotope has 6 protons but different number of neutrons. One has 6, the other has 7 and the last one with 8 neutrons. We name these isotopes as carbon 12, carbon 13 and carbon 14 respectively. Now this was about the different forms of the same element. What if I tell you that atoms of 2 different elements can have the same atomic mass? Yes. Let's understand this with an example. We take 5 different elements: sulfur, potassium, calcium, chlorine and argon. Now if you notice, in each case the number of protons and neutrons is different. It's 16 and 24 here, 19 and 21 here, and so on. That's right. However, the total number of nucleons in each sums up to 40. What do we mean by a nucleon? A nucleon is a proton or a neutron. Yes, each thing present in a nucleus is a nucleon. So the total number of nucleons in an atom is the sum of protons and neutrons. We can also say that the total number of nucleons in an atom is its atomic mass. Yes, understand this well. The total number of nucleons, which is nothing but the sum of protons and neutrons, is the same as the atomic mass of the atom. So coming back to our example, there are 5 different atoms here. Though the number of protons and the number of neutrons is different in each case, the total number of nucleons in each is the same, which means the atomic masses are the same. How? Yes, it's simple math. One of the sulfur isotopes that we have taken as an example has 16 protons and 24 neutrons. So the atomic mass of this isotope has to be 40 units. That's 16 plus 24. Next is the potassium isotope having 19 protons and 21 neutrons. So again, we get the atomic mass as 40 units. And similarly, we get the atomic mass as 40 units in each of the remaining cases. Such atoms, or rather isotopes of different elements having the same atomic mass, are called as isobars. The term arises from Greek, iso meaning same and baros meaning weight. Remember, if we consider two isobars, the number of protons and number of neutrons in each case will be different. But the total number of nucleons or the atomic masses will be the same. So far, we've understood subatomic particles and a few important concepts related to atoms.
Now students, after knowing about the isotopes and the isobars, now we will see some of the applications of isotopes. So applications are nothing but the uses, or you can simply say the advantages. Okay, everything is same. So applications, uses, advantages or benefits, all are same. Okay, so what are the applications of isotopes? Let us see. An isotope of uranium is used as a fuel in nuclear reactor. An isotope of cobalt is used in the treatment of cancer. An isotope of iodine is used in the treatment of goiter. So there are three applications of the isotopes. Firstly, an isotope of uranium. So uranium is an element, and the isotopes of that uranium, it has been used as a fuel. Okay. This uranium, the isotope of uranium, it will be used as a fuel where? In the nuclear reactors. And what are nuclear reactors? They are the tools which are used in the research, right? So this is used as a fuel in the nuclear reactors. Which one? Uranium. The isotope of uranium is used as a fuel in the nuclear reactor, whereas an isotope of cobalt. Okay, cobalt is one more element, and the isotope of cobalt is used in the treatment of cancer. So cancer, it's a deadly disease which is caused due to the unusual growth of the dead cells or the unhealthy cells. Okay, and you have heard about this cancer disease. So one of the isotope of cobalt, it will be used in the treatment means in the curation of the cancer. And one more, an isotope of iodine. So iodine is an element whose isotopes are used in the treatment of goiter. Okay. So cobalt is used in the isotopes of cobalt are used in the treatment of cancer, whereas the isotopes of iodine are used in the treatment of goiter. Now this goiter, it's also a deficiency caused due to it's a disorder caused due to the deficiency of iodine, and it is the gland, thyroid gland is responsible for the disorder of goiter. So you have seen the people having the swollen neck. That means their neck will become so big. So that disease is nothing but the goiter, and it is caused due to the deficiency of the iodine. Okay, and to cure this goiter deficiency means kami. Okay. So if there is lack of iodine in our body, in our blood, then it leads to the goiter disorder. And to cure this goiter, the isotopes of iodine will be used. So hence these are the three applications of the isotopes. Application means uses. So the isotopes of uranium will be used as fuel in the nuclear reactors, whereas the isotopes of cobalt will be used in the treatment of cancer, and the isotopes of iodine will be used in the treatment of goiter. So goiter is a disorder caused due to the deficiency of the iodine. So that's about the lesson structure of the atom. So here it's the end of this chapter. In the next class we shall start another new chapter. Before that, complete the notes of the lesson that has been completed. Okay. Already I have informed you about the notes. Once again I will just repeat it. So you have to keep two separate notes, one for classwork. That means classwork means that should be the clean notes. You have to write the only notes that I used to forward you as a PPT images, right? That notes only you have to write in the classwork, whereas this video explanations and the homeworks that you have to maintain separate book. You can write that in the science homework book only, okay? But you have to complete and you have to submit on the prescribed timetable.